Okay, so I'm going to do the next part of this video, just a few applications of derivatives, which we will begin to learn more and more of as the semester progresses. Okay, so to begin with, we got this function, and we're going to find the equation of the tangent line at that particular function at x equals 4. Okay, what you always have to do on this, first of all, is find the derivative, because you have to find the slope of the tangent line. So anytime you find the slope of the tangent line, that involves a derivative. So we're going to rewrite this as f of x equals 2x to the 1/2 power minus x. Okay, and we're going to do the derivative. Okay, so f prime of x, we now know the shortcuts. The power rule would say 2 comes down, it's a constant, minus 1/2 x to the 1/2 minus 1. And then the derivative of x is -1. Remember, that's a linear term. So the derivative, or the slope of y equals -x, is -1. Okay, it looks like the 2's cross out. So it looks like we'd be left with f prime of x is equal to x to the -1/2 minus 1. Now I'm going to move this up here and kind of complete this. So we have f prime of x equals 1 over x to the 1/2 minus 1. That minus 1 is just outside of that expression. So you would end up with 1 over square root of x minus 1. Because you want to start by finding the derivative, then you want to kind of continue with the slope. So the slope of that tangent line is going to be f prime of 4. That's the x value that we're interested in. So we would just go 1 over square root of 4 minus 1. Again, I'm just plugging the 4 into the derivative. So that would be 1/2 minus 1. So that's 1/2 minus 2/2. So therefore, the slope of the tangent line is going to be -1/2. Okay, so that's kind of a key piece. We get the derivative and we get the slope of the tangent line like that. Okay, so really the third thing that you need to do is you need to evaluate the function. So we need to find a point on this graph. So what we're going to do is we're going to find f of 4. So we're going to plug into the function. So we get 2 times the square root of 4 minus 4. That's 2 times 2 minus 4. So that's 0. So therefore, what we have is we have a point for 0. And the 0 kind of makes this kind of a little bit easier to deal with then. Okay, and then step 5, or step 4. 4 comes after 3. Okay, step 4 is we're going to use the point slope formula. I'm just going to kind of write this over here, maybe at the side here where I have a little bit of room. So step 4, we have y minus y1 equals m times x minus x1. So you will be asked to find equations of tangent lines frequently in this class. This is always going to get you there. So we need to know two things. We need to know the slope of the tangent line, and we need to know what we call the point of tangency. The slope came from doing the derivative. Okay, that slope was right here, -1/2. So that goes in there. Okay, the point we found here. So the x value is 4, so that goes there. The y value is 0, that goes in for y1. Y and x are variables that are going to be in your answer. So you'd have y minus 0 equals -1/2 times x minus 4. And then we're going to just solve that for y, get that in mx plus b form. So this is y equals -1/2 x plus 4 over 2. So that would be y equals -1/2 x plus 2. So that would be the final answer of that problem. That's the equation of your tangent line right there. Now we're going to close out this problem by doing something on our graphing calculator to see visually if what we calculate even looks right to us. Okay, so I'll try to kind of put this stuff over here at the side, and you should do this right along with me here. Okay. Okay, so put in the function Okay, so I'm going to go to y1. I'm going to take all the crap out of here. And then I'll put in the function. So the function is 2 times the square root of x minus x. So that's your function. So we're going to go ahead and just start by graphing that. So standard window, zoom 6. And let's get, some good points. So instead of just winging it and just drawing the shape, get some accurate points. Why are those arrows there? Well, because you can't do a square root of a negative number, see? Okay, so let's find some good points. There's a good one. Okay, 0, 0. I'll plot that. 1, 1 looks like a nice good point. 4, 0 is kind of a good point. And that may be good enough for what we're going to do. I'd like to just kind of look at whole numbers if I can find them. There's 9, negative 3, so I'm going to go ahead and go over 9 and down 3 like that. Okay, then I'm just going to sketch in the shape and label that. Okay, so that is f of x is equal to 2 times the square root of x minus x. Okay, so that's what that is. Now what we'll do is we can graph this. So hopefully you don't need a calculator to do this. This is a line. The y-intercept is 2, so put a dot on 2. The slope is negative 1/2, so what do? You go down 1 over 2. So from here, just go down 1 over 2. Oh my goodness. I think that I may have made a mistake. Well, that's good. That's why, because this isn't going to look like a no tangent line. So maybe you guys have already seen where I made a mistake. I'll go back and look over this, and I do that every now and then. Not intentionally. Well, that is a tangent line. What am I doing wrong? Oh, gosh, I'm not counting right just because I can't see. Okay, I'm doing all right. I just can't see what the heck I'm doing because it's too small. Okay, so here we go. So from here, we go down 1 over 2, down 1 over 2, and so forth. Now, we can sketch in the tangent line, and I think that looks pretty good. So remember, we have the point 4, 0. So what I'm going to do is just kind of put a dot on 4, 0. So we call that the point of tangency. You can see this a little bit better on the graphing calculator. So that looks like a good tangent line to me. It's only touching in that small region at that one point. Okay, so that's what that looks like. And again, you can tell if you trace it 4, which is what we are interested in, I think you can tell that's a tangent line. One kind of cool thing you can do if you've never learned how to do this is called zoom box. So if you go zoom box, I'm going to draw a box around the area that I'm kind of interested in. I'm just trying to show you that this is going to touch in one place. So I just kind of get draw a box around this. Once I get that cursor where I want, I press enter. Then I can go to the right. And I'm just sort of drawing a rectangle around this thing. So go down, and this is so cool. I just think this is the most satisfying thing in the world right here. So now I just zoom in. Oh, okay, that looks like a tangent line. See, what happens is when you keep zooming in further and further, the curve is almost the same as the line. That's another good way to look at that problem. Okay? All right, and yeah, that's satisfying. All right, so let's go to this next example then. So with the next one, the question is determine the points on the graph or this function where the tangent line's horizontal. So the thing is, if the tangent line is horizontal, then what is the slope? Okay, the slope is 0. Exactly. All right, so what we need to do is we need to take the derivative of this. So what we're going to do is f prime of x. Okay, the derivative of 9 is 0. The derivative of x squared is 2x. Therefore, f prime of x is equal to negative 2x. Okay, so we got that. Okay, so we do that. Now, step 3 would just be set the derivative equal to the slope of the tangent line. And the slope of the tangent line is 0 because it's horizontal. So the derivative is negative 2x. The slope of a horizontal line is 0. If you solve that equation, that will tell us where the tangent line is horizontal on this function. So that's easy to solve. You divide both sides by negative 2. So x equals 0 is where this happens. Okay, so that's the answer. Okay, so let's just go ahead and do this on the graphing calculator and just graph out the function I gave you. Hopefully you know this is a parabola, up 9, vertically, it's reflected over the x-axis. So we just go 9 minus x the second. Need to go back to a standard window, so zoom 6. And that's our graph. Okay, and let's just kind of sketch a graph on this and talk about whether this makes sense to us or not. So you'll find that you have a point 3, 0, you have a point negative 3, 0, and you have a point 0, 9. So that's how the graph of that goes. Is kind of like that. So that's f of x is equal to 9 minus x squared. Okay? So, what's the deal at x equals 0? If x equals 0, the tangent line is horizontal. Okay, just think about that a little bit on that then. So actually, the equation of the tangent line would be y equals 9. Okay, so that would, the idea on that is just by taking the derivative and set it to 0, we can figure out kind of like this maximum on that graph with calculus methods. One of the things we'll use derivatives for is finding maximums and minimums of functions. There's a lot of application to that. Okay, so let's see. I'm going to have you go to the next page, pause the video, and see what you come up with on these. Okay, so let's go ahead and check and see if you're coming up with what I'm coming up with. So the first one, you have a cubic function, and you should have got 2 x values that will have a horizontal tangent line. You should have got 5 over 3 and negative 1. Okay, so what I did is we know that the slope of a horizontal line is 0. We need to take the derivative, so you need to check that you got negative 3x squared plus 2x plus 5. That's your derivative. Now set that equal to 0. Now you solve this by factoring. You could also go the quadratic formula. I did this maybe slightly different than what you might think to do. What I like to do is anytime the coefficient of the second power is negative, I like to just multiply both sides by a negative, and I think the factoring's easier that way personally, so I just change all the signs really and get 3x squared minus 2x minus 5, and then the factoring goes like this. Okay, so I get 3x minus 5 times x plus 1. Solve those two equations, that's how I get 5/3 of negative 1. So what you'd find on this, what I did is I just, found some good points. I plotted several good points. That's my function. F of x is what I have in green. And then you can see on here if x is negative 1, so you got a horizontal tangent line. 5/3 is actually 1 2/3. Kind of hard to tell exactly, but 1 2/3 looks like a pretty good place where you also have a horizontal tangent line. Okay, so that's what you should come up with on that. Next problem. Let's see, this is the tangent line problem, so I'm giving you this function, negative 3x squared plus 2. You want to find the point of tangency. You can either do that in step 1 or step 2. It doesn't matter. I went ahead and just, since I gave you x equals negative 1, I plug in there. That should be a negative 1. I made that mistake, but it doesn't really make any difference. So you get negative 1. So basically, you end up with this point of tangency. Right? Then the second step is you take the derivative. The derivative of this function is negative 6x. And then you find the slope of the tangent line by evaluating the first derivative at negative 1. Why negative 1? Because that's what I gave you. That's what we're interested in. So negative 6 times negative 1, 6. So the two key things you got to get are the point of tangency and the slope of the tangent line. Once you do, then you just plug into this point slope formula and work that out. You get y equals 6x plus 5. Okay, and then the graph goes like this. There's a couple of things that are kind of nice on the graph here. This is my my function. Here's my tangent line. Notice this point right here, -1, -1, is the point of tangency. So you can tell visually that that looks correct. Okay. Okay, so pause on this if you need to, right now, if you need to look at either of those two problems for a few minutes. Otherwise, I'm moving to the next page. Okay, so I'm going to do one more thing to close off this part of the section. I'm going to do this video, I think, in 5 parts. So this is just sort of a way to help you review all the derivative rules we learned. This is a table of values. These are the x values. 1, 2, 3, 4, 5. This is the value of the derivative of f prime, of f, and then this is g prime of x. So what we're going to do is find the derivative of f of x plus g of x. Okay, so we have f of x plus g of x. Okay, well, if we do the derivative of this, which is what we're ultimately asked to do on this, well, the rule we learned is you just do the derivative and then sum those together. That's the sum rule that we learned. So that's what the derivative is. Then we can go ahead at x equals 1. Now, sometimes you'll see me write this like this. I say, okay, I'm doing the derivative. Now I'm evaluating at x equals 1. So what I would have is I would have f prime of 1 plus g prime of 1. Now I'm going to look this up on the table. So notice that if x is 1, f prime of 1 is 3. That's what that is. And g prime of 1 would be 2. That's how you read that table. So 3 plus 2 would give you an answer of 5. Okay? Okay, the next one you're doing the derivative of 1.5 f of x. So when we do the derivative of 1.5 f of x, you got to know the rule that we learned. The constant multiple rule says that you can take the constant and then just multiply by the derivative of the function. So you would end up getting 1.5 times f prime of x. Then you want to evaluate this at x equals 2. All right? So that means you're going to have 1.5 times f prime of 2. Again, you got to look this up on the table. Okay, so if x is 2, then f prime of 2 would be 5. So you get 1.5 multiplied by 5. Okay, and then that would give the answer of the problem. So that's what, 7.5, I think? Use your calculator if you want to. I think that's 7.5. If it isn't, you can laugh at me. Okay, 7.5. All right. All right, so just kind of learning to apply the derivative rules is what I want to finish this section up on. Okay, the next one, same basic idea. Now we can write this like this if we want to. What we're really doing is we're doing the derivative of 2x, and then we're doing the derivative of 3g of x. Again, the derivative of a difference is the difference of the derivatives. So the derivative of 2x is 2. And then this could be written as 3 times the derivative of x like that. Okay, then you want to just evaluate this derivative at x equals 4. So the 2 is just a constant. You just bring it down. That's a part of your derivative. Then you would have 3 times g prime of 4. And then look up what g prime of 4 is. When x is 4, g prime is 1. So it looks like what you get on this is 2 minus 3 times 1. Therefore, that's negative 1. So this is nothing more than, can you read a table and do you know the basic derivative rules that we've gone through? So that's the idea. Okay. Now I'm going to close off this part with the next thing here. We're going to just look at a graph, and this is kind of doing a similar idea. Can you interpret graphs correctly is what this is saying. So first of all, in this problem, capital F of x is defined to be the sum of f of x and g of x. And in this diagram, f of x is the one in black. G of x is the function in red, as the diagram shows. So what this would be is if you're doing f prime of 2, this is defined to be this. So that would be little f prime of 2 plus little g prime of 2. And you can get that information from this graph here. Okay? So let's look at that. Okay? All right. You got to look at what's happening to this graph when x is equal to 2. Okay? You have two derivatives going on. On the black graph, you got to figure out what the slope of this line is. Okay? So we got to do the slope here. So the derivative is the same from 1 to 3 because it's a line. So it looks like you're going 1, 2, 3, and over 1. That looks like down 3, right 1. So that would be down 3, right 1. That's what the slope is. Okay, then we got to do the derivative of g of x. Okay, that slope is up 1 over 1. So we're going to have plus 1 over 1. So we end up with negative 3 plus 1. Therefore, that's equal to negative 2. Okay, that's how you interpret that. Okay, the reason we have the ability to do that is because they're lines, and we can figure out what the slope of a line is by looking. Okay. Okay, so let's see. See what you can do on the next two. I just want to let you think through that for a minute, and then come back and check, and then we'll be done. Okay, so you should have got negative 8 on B and 0 on C. That's what I got. I'll kind of talk you through what I did here. The definition of G prime is 3f of x minus g of x. So if I'm doing the derivative, I'm going to do 3 times f prime of 2 minus g prime of 2. We already found these slopes. The slope of f, which is the black graph, at x equals 2 is you're going down 3, right 1. The slope of g of x, which is red, up 1 over 1. So you get negative 9 minus, okay, teacher, okay, now you can laugh at me. Okay, you get negative 10. Just checking. Negative 10, okay? All right. The next one I got 0. Here's how I did it. Okay, by definition, capital F was f of x plus g of x. So we're really just doing f prime of 5 plus g prime of 5. Now, if you look at x equals 5, the black graph now has a slope of 1 over 1. So that's what that is. The red graph has a slope of down 1 over 1. So this slope is negative 1 on that line, positive 1 on that, so you get 0. Okay, so that'll wrap us up there. That'll give us the third part, and then the rest of the video will be in 2 parts. We're going to go over the quotient rule, product rule, and the extended power rule is what we're going to look at. All right, so good luck.